Oh yeah, in this video we're going to go over how to verify solutions to differential equations. This is one of those parts of a calculus class that some calculus teachers go over and some do not, but I'm covering it all, so let's dive into it. Here, right below, is an example of a differential equation we're going to learn to solve later in this chapter, so don't fret about how scary it looks. It's got x times y prime minus 3y equals 0, or it could be written as x times dy dx minus 3y equals 0. Our goal is to find a function f of x, or y, such that when we plug it into this, we get 0. Meaning, when we take the derivative of f of x and multiply it by x, and then subtract 3 times f of x, we'll get 0. That's our goal. How we do that, that's down the road. For right now in this video, it's check to see if a given value, f of x, is indeed the solution. So that's it. That's what the solution to a differential equation is. It's the f of x value that makes a differential equation true. All right, so the first problem says verify y equals f of x is a solution to the differential equation. So here's that y equals f of x function. We want to verify it's a solution to this. How do we do that? Well, essentially what I always say to my students, I'll say to you, is follow the cookbook recipe that's right here. This is telling you, this differential equation is telling you, take the derivative and subtract x cubed, and does it equal 0? Well, let's take the derivative. dy dx is equal to 4 times x, you get the 1/4 just chilling, 4 times x to the third. The derivative of a constant is 0, and so that ends up being 1/4 of 4, which is x cubed. So dy dx is x cubed, so we take that and evaluate it in for dy dx. So x cubed minus x cubed is equal to 0, and that's really a question mark, and 0 is equal to 0. So yes, it's been verified that this solution, or this equation I should say, is a solution to that differential equation. That's it. Follow what the differential equation tells you to do. All right, we're going to keep doing that just to get used to it. Verify y equals f of x is a solution to the differential equation. So again, this tells us take y prime, multiply by -5, subtract 3 times y, and the question is it equal to 4 times e to the minus x? Well, verifying it means it probably is. So y prime is just another way of saying dy dx. I'm switching up the notation so you're used to seeing it every way. Y prime is equal to 2e to the minus x times minus 1. Remember, it's e to the stuff, d stuff. So that ends up being minus 2e to the minus x. So there's y prime, there's y. Let's plug it in. So this says take -5 times y prime. So -5 times y prime is -2e to the minus x. We found y prime because the differential equation told us we'd need that as an ingredient. Think of it as like we're preparing ingredients for a meal. And here we are making that meal. Minus 3 times e to the minus x times 2, right? That's y that you're plugging in. So it's 2 times e to the minus x. And the question is that equal to 4 times e to the minus x? Well, let's see. All right. Now, -5 times -2 in most places is 10 e to the minus x. 3 times 2 is 6. We've got that minus chilling. 6 e to the minus x. Question again, is it equal to 4 times e to the minus x? Looks like it is. 10 e to the minus x minus 6 e to the minus x is 4e to the minus x, which is equal to 4e to the minus x. It's been verified. All right, we'll keep going. One more problem with verifying. This says verify that that is the general solution to this. What makes it a general solution is that there's a c there, right? We saw that before actually in the first problem we went over in this video. Then we're going to find the particular solution to this general solution given x equals 1 and y equals -2. We'll get to that in a second. So to verify again, we're going to follow exactly what this tells us to do. It tells us take y, wonder what y is, multiply it by y prime, and then subtract x. And that's equal to 0. So this one's going to be a little bit funkier with how we do it, but we can rock it for sure. Okay, so what do we do? Well, first things first, let's take a derivative of this. We're going to do that because, and there's 2 ways we can do this, because we have a y prime in there, but I'm going to be a little sneakier. I'm going to set this equal to y prime. Y prime would be equal to, you'd add x and divide by y. So I get y prime alone. So now what I can do is I can take the derivative of this and see if it's equal to the same y prime. Sneaky. So I think that that's easier to verify this way than it is to solve for y, plug in for y, solve for y prime, plug in for y prime. I think that's harder to do, personally. Okay, so we take a derivative of this. It's 2x minus 2y times y prime, which is equal to 0. The derivative of a constant is 0. We'll solve for y prime. So we'll subtract 2x. We get minus 2y y prime equals minus 2x. Divide both sides by negative 2y. That's going to give me negative 2x over negative 2y. And that ends up equaling x over y. And so we can plug that into there, and x over y equals x over y. So it's been verified. So that is a shorter way of doing that. Why I didn't do that in these previous problems is because, well, I had everything solved for y to start in this one, and in this one here as well. So I thought this problem was a better bet to solve for y prime first. Just how I do it to show it. Some professors or teachers will be like, yeah, I don't like you doing it that way. We want you to solve for y in this equation and plug in and find y prime and plug in. And we can do that, but maybe not the best way to go about it. So I'm going to go over that one now just so that you see it both ways. So here's the other way. So the other way, again, is following this recipe exactly as it says. The derivative of this we already know is x over y. So you'd have y times x over y minus x, and does it equal to 0? Well, the answer is yes. The y's divide out, and you get x minus x is equal to 0, so 0 is equal to 0. So that doesn't seem that bad. You might have been like, dude, Groden, why not do it that way? We had to solve out for the derivative first to get there, right? Which I guess, technically we had to do it for the other way too. So now that I think about it, either way works for me, but I prefer that first way that I showed. It's just the natural way I went about it. But the second way works too. All right, very cool. This next part says find the particular solution to the general solution given x equals 1 when y equals negative 2. Yo, this is just saying solve for c. That's it. So x equals 1, y equals negative 2, we're going to plug in. So when x equals 1, we square 1. We subtract the square of y, which is negative 2, but that quantity gets squared, equal to c. And so that's going to be 1 squared minus 4 squared, or minus 4 rather, which is equal to c. So c equals negative 3, 1 minus 4. But that's not our particular solution. The particular solution is this plugged in like we've done in the past, and that's x squared minus y squared equal to negative 3. Very interesting one right there. Okay, that's it. I hope that you felt good in that video. A couple different ways to solve that last one. I'll see you in the next one. Slope fields. Can't wait for it. Peace.